Welcome to surface area of cones. So we're going to do one cone problem, and we're going to have a little review of all of our, well, not all of them, but at least one kind of each of our three-dimensional figures, finding surface area, lateral area, and volume. All right, so first the cone here. All right, just a reminder of our formulas. So the lateral area is just the area around the cone, not including the base. All right, so that's going to be circumference times the slant height. But because it's triangular, it's only going to be half circumference. So normally circumference is 2 pi r. Lateral area for cone will just be pi r, right? Because it doesn't have a rectangular area around it. It has a triangular, right? It even looks like a triangle. So it's going to be pi r, and then we want, oops, it's supposed to be an r, and we want slant because we're measuring the outside. There we go, pi r times the slant. Surface area, just add in the base. So the base is a circle. So we have, and let's use our factored formula. So that's going to be pi r times r plus L. And then our volume is just the area of the base times the height. Now, not the slant, but the height inside the cone. It doesn't have the same volume, of course, as a cylinder. So instead of the area of the base times the height, it's going to be 1/3 the area of the base, pi r squared times the height. Right? Now, to add a little excitement to this problem, make it a little more interesting, we only have one side. The only side we have is the radius. Right? So the radius is 4 meters. We don't have the slant or the height, but we have an angle. And it's a right cone, so the height here is perpendicular to the radius, and together they make a right triangle. So we could use our trig ratios to find our missing sides here. Okay? Right? So I'm going to switch colors here. I want to kind of color code this. I've already used red, green, blue, and black, so let's use purple. And let's find the height of the cone. So the radius is opposite that 30-degree angle that we have, so this is the opposite side. And then the height is adjacent to that angle. So which of our trig ratios uses opposite and adjacent? Well, that would be tangent. So if we take tangent 30, that would be equal to the opposite side, which is 4. And let's use h for height over our adjacent side, which is h. We need to get the h out of the denominator, so we're going to multiply both sides by h. That'll cancel. So now we have h times tangent 30 equals 4. And now we need to isolate h, so we'll divide both sides by tangent 30. So h is equal to 4 divided by tangent 30, which is, I know it's going to be 6, because I remember what the number was. Oops, and I just opened up the wrong thing. All right, so it's going to be, so we're going to take 4 divided by tangent 30. So that was 6.928, and so on and so on. Let's round that to 6.93, 2 decimal places. All right, so now we have the height of the cone. And now we need the slant. I'm going to switch colors. All right, so the slant is opposite the right angle, so that is the hypotenuse. Make sure you do not calculate with the 6.93, not because it has a decimal, but because we rounded, and there were many more decimals that I did not write down. We need to use the number we know, the 4, otherwise we're going to have rounding error. All right, so opposite and hypotenuse, well, that would be sine. So now sine 30 is equal to the opposite side, which is 4, over the hypotenuse, and let's call that the slant over the slant. Let's multiply both sides by the slant there. So we have slant times sine 30 equals 4 divided by slant times slant. That will cancel out. So we have the slant times sine 30 equals 4. Let's divide both sides by sine 30 so we can isolate slant. Right? So slant is equal to 4 divided by sine 30. Now let's put that into the calculator. So we have 4 divided by sine 30, and that is, look at that, the pretty number, 8. And actually I knew it was going to be 8 meters, not because I remember the answer, but because this is actually a special right triangle. So actually I'll tell you something else special about this triangle. So this is a 30, 60, 90. And when you have a 30, 60, 90 triangle, the sides always have the exact same, well, in any triangle, the sides are going to have the exact same relationship as every other triangle that has the same angle measures. Not the exact same numbers, but the same relationship. But what's special about the 30, 60, 90 is that they're very, very pretty numbers. Right? So the short leg, and the shortest leg in a triangle is always opposite the shortest side. So opposite the shortest angle. So the smallest angle is the 30-degree angle. And so that short leg opposite the 30-degree angle, in this case, is 4. The long leg, I keep missing the E in the word leg. The long leg is going to always be opposite the 60-degree angle. That's always going to be whatever the short leg is times the square root of 3. So in this case, it would be 4 square roots of 3. So we could use that decimal, but instead it'll be easier to calculate with 4 square roots of 3. And actually, if you put into your calculator 4 times the square root of 3, you find you get 6.928, etc. The exact same number we got from 4 divided by tangent 30. But let's use the exact answer. That's what's actually very special about the 30, 60, 90 triangle. And actually there's 2 special triangles. One's the 30, 60, 90, the other one's the 45, 45, 90, is that we don't have to use trig ratios, and we can always have exact answers rather than rounded answers. Right? So, and then the last relationship is the hypotenuse. The hypotenuse in a 30, 60, 90 triangle is always going to be equal to the short leg times 2. So in this case, it was 4 times 2, which was 8. So that's the special relationships with the 30, 60, 90. So let's use the exact answer here for the height. 4 square roots of 3 meters. Right? And so now let's find the 3 measurements: the lateral area, the surface area, and the volume. Right? So the lateral area, I'll put LA for lateral area, is going to be pi times the radius, which is 4, times the slant height, which is 8. So that's pretty easy to calculate out. The lateral area is just 32 pi meters squared. For the surface area, let's use that. We're using the factored formula this time. So the surface area is pi times the radius, which is 4, times the radius plus the slant. Oops. 4 plus 8. Right, so it's going to be the surface area is equal to pi times 4 times 12. And that would be 48 pi meters squared. Now the surface area is just the lateral area plus the area of the base. So the area of the base would be pi r squared, or pi times 4 squared, or 16 pi. And notice 16 pi plus 32 pi does equal 48 pi. So it's kind of a little way to check ourselves here. And practice that other formula. 48 pi meters squared. And then the volume, we'll just do that right under the V there. Right, so, and this is, by the way, this problem, as well as the review, is in the new set of notes I gave you in class and posted on Schoology. Our volume here is going to be 1/3 times pi times 4 squared times 4 square roots of 3, because we use the height. And then we'll just, I can actually move this over a little bit so the volume isn't so crowded, because I have all, this space in the middle there. So I hope you wrote down this relationship. If there's time, I might have us work a little bit more with those special right triangles. They're really easy. But if not, don't worry. We'll work with them in Algebra 2. Right, so volume is 1/3 times pi times 16 times 4 square roots of 3. When you have a radical and a number, you just add the numbers outside the radical with any other numbers that aren't in radicals together. And then if there was more than one radical, it's always radical times radical. So the numbers under a radical can get multiplied together. The numbers not in a radical get multiplied together. So, and there's not that much to multiply actually. We're going to have 16 times 4, which is 64. And there is no other radical, so square root of 3. And then you can't simplify 1/3 with the square root of 3. The 3 is inside the radical. The 1/3 is not. So we can write that as 64 square roots of 3 over 3. And then don't forget our pi. And actually, I actually want to reverse that, because if I put the pi on the other side of the square root of 3, it kind of looks like the pi is under the radical. So let's write 64 pi square roots of 3, and then all over 3. And this was meters cubed. And we're all done. Right, so hopefully this was a good review for trig functions for you. You'll learn something new, as well as you got to practice. Oops, let me put that number in here. Your surface area and volume formulas for the cone. I think I am going to end this podcast and finish up in the next podcast, so the podcast doesn't get to be too long. Right? And we're going to review through all the formulas again with a sample problem from each category. All right, bye for now.